So we have our next speaker joined us live, Aldis Erglis, who will tell about linking datasets. So sit tight and ask questions. Aldis, welcoming you live.
Yeah, thank you. So on this session, yeah, can you hear me?
Yes.
On this session, I will focus more on this correlation causation side. I will cover linking data sets on other session next week. So it will be more about how to understand correlations and use correlations, because it's, let's say, most important, I think, very important part of any analysis. And if we talk about start talking about analytics and especially correlations, we need to understand that why we are doing that and what actually these correlations and then the report show us. And as reporting is a part of business intelligence, we are doing then. Actually, the business intelligence is a way how we explain performance of something, usually performance of an organization or performance of sales team. If we particularly talk about sales, we are explaining how it works. And I like it, the previous presentation, where the idea to explaining how and why was the main goal for this report creation or report visualization. And if we talk about correlation, it's very important to distinguish it from causation. And we have plenty of examples when we talk about what's really correlation is. And correlation, technically or statistically, it's a kind of association between two variables, and that they influence each other in some way. And for example, here we see the correlation between chocolate consumption and Nobel Prize laureates for 10 million people population. And what we see that usually what means correlation, that if we draw the line here on the 45 degrees, where it means that if one grows, then other parameter also grows. So in this case, we see the strong correlation. And here is a even parameter for that, for the correlation with the r small r. So we see that there is a correlation, strong correlation between chocolate consumption and Nobel Prize laureates. It means that we could say that if you eat more chocolate, you will have more Nobel Prize laureates. But as a human, so data will show you that. But as a humans, we understand that it's not really the truth. So there is other reasons, other other parameters that make its influence, and maybe economics and so on. So and that is so we need to distinguish correlation from causation. Or for example, if you will write in the search engine correlation and causation, you will find plenty of examples when for example, here we see the correlation between number of people who dropped by falling into pool and the films Nicolas Cage appeared in, and we see that almost the same. So it's correlated. Or here is the total revenue generated by arcades and computer science doctorates awarded in the US. We see strong correlation, but it doesn't mean anything. So be careful with correlation and distinguish it from causation, but still it's very important to use this correlation and different mathematical techniques, because they are helping us to explain how we work. So we need to use it together. So correlation together with causation. And for example, if you look at the method that you could use, machine learning techniques that you could use right away in Power BI, it's clustering. So if you draw a scatter plot, there is a function create clusters. So it will create the clusters and will do it could be used for segmentation or for something else, but it will never tell you why these clients or why these people are in this or that cluster. So you need to look at the cluster details and label it. So technically speaking, you need to look at the data for cluster 1, for example, see what's there and say and name it this cluster. You say, oh, these are large clients. So algorithm will not say you, but we will find this association. Or forecasting we discussed yesterday. It will do us some forecasting. So it's an extrapolation technique, but will not say you why. So it will say that, yeah, it will increases or decreases, but will not say you why it will decrease or increase. And the best way how to understand correlation in Power BI is to use this explain, increase, decrease, when Power BI will show you the all possible associations. It will not show you just one, because just one is answer to the why question. It will show you 5, 4, 10 correlations, different associations, and you as an analyst, you need to decide which of these correlations actually is causation. And there is a separate like science about causation. The leading expert currently is Judea Pearl on this. You could find a lot of information about causation by finding Judea Pearl. He's also inventor of Bayesian networks that is used for in machine learning field. And the idea of causation, how he explains causation, and there is 3 levels of causation in a ladder of causation. First, we seeing, that we could see and understand associations. By intervention, that we are predicting something, or imagining, that we imagine something that and do a modeling in our mind and then act. And there is a causation ladder by Judea Pearl, and we see that on association level there we have animals and machines, like machine learning and AI. It's actually on the seeing observation level, and we see that only humans could predict something using interventions and counterfactual approach. So it means that in data, you can't find an answer to the why question. You will have the answer to the how much, when, who answer questions. So what it means for sales data, if you look at it particularly in sales, by seeing, yeah, we could explain increase, decrease, by doing what will happen if we double price, and by imagine what kind of product to introduce to the market. Though that is second and third question could be answered only by some using causation. Let's skip it. And why causal diagrams? First, most of the decision making is, even if it's data driven, it's data plus something. Usually it's intuition, but intuition, it's very hard to explain. But causalities is something that we can explain. But let's look now at the correlation capabilities in Power BI. What we can do with the Power BI. I'm sharing now my Power BI. And I want to show you three types of visuals. Let's start with this correlation plot. And in Power BI, you have a couple of R diagrams. Let's look. And for correlation purposes, the best one is correlation plot. Comes from R language, so you can see this one. It shows you correlation between several variables. Like if in this chart the large blue, dark blue means correlation, high correlation. If it's becoming it's still blue, but lighter blue, and smaller, it means less correlating. If it's red on the other side, it's is negative correlation. And we could display this correlation in different ways. So it's from visualization perspective, very many options. So, and there are two ways how to do that. One, you could just load this visual, but I want to show the second option. And it's write a little bit R code. And you will see that it is not very hard. So as correlation corplot is a R package, you could find description about this package, and you could see all the possible visualization options, how you could do that. And there is a code for that, how to like put a figures, put a different shapes and so on. And as for all the R visuals, there's strong mathematical background behind that, so we can be sure that it is it will be work correctly. So let's create a new page, and I will use this R. So in your Power BI, you see there's R and PyY letters as a visuals. R is R script visual. PY is a Python. And if we click R, let's say, and you need to have R library installed, so it's easy to find and install it. And when you have it here, you could add different data as an input. So, and here at the bottom you could write some R code. In this case, I will just copy and paste this code. What we have, the import of the library corplot, and then we are importing predefined dataset empty cars. So we are not using own dataset from Power BI, but this preset. But we could, of course, you could see the data frame sales dataset. It's data that we are actually put in values, but for the demo purpose, I just put this one. So, and click run. And I see there, I have this core plot, nice chart. Let's look at the, like, if I want to put figures, and you see that method means, method should be a number. I go back to here, and instead of circle, I put number. Run it, and it shows a number. And I could scale it. I could change different parameters, and it looks very nice. So visually, if you need to create some more complicated charts, you could use R to draw like 5-10 lines or chart on chart. So it's best way how to do that. Okay, that's correlation. Let's look at another example that also provides correlation, and it's key influencer chart. Let's create this one. You have it in Power BI here, key influencer. And how key influencer works, it's actually, if you look at what's created here, I have a automobile data, and there is a one parameter that I want to analyze, in this case price, and then I put here I put body style, horsepower, drive wheels, make, and other parameters, and this key influencer chart shows me actually if, like, when the influence price increases, the average of price increases by, so when drive wheel is rear wheel drive, the average price increases by 10K. So it's a much influencer. Second one, if engine size go up, then price is 3.76K more. And horsepower is a third parameter, and we see here a correlation plot for that. We again see this correlation line, this linear correlation line and how the values are spread for this. So we definitely see this correlation, and we could select decrease, and we see again that there is a correlation between in this case, then when the drive wheels is four wheel drive, so the price decreases by 9.6K. So that is nice way how to find the correlations. And another thing where we have maybe not so much correlations, but let's see that explanation that also gives us nice view and understanding associations, and it's a visual called the composition tree. It's available in latest versions of Power BI Desktop. So if you click at the composition tree, again you say what to analyze, like in this case price, and then you could put many parameters, like I put engine size, make, body style, fuel type. And how it works, we have this price, and now we click on the plus button, and we could go to body style or to any of these parameters, but we could also ask for highest value or lowest value. It's again built on top of association. If we say that show me the highest value for the price, and we see that absolutely the highest value we have that for gas automobiles, then we say, okay, let's split this highest again, this highest value on top, and we see the body style, and we see that how the sedan, hatchback, wagon, sorry, how they are divided. And in this case, we are interested in sedan, and we say again, show me high value for sedan. In this case, how the price would, and we see that BMW sedans on gas that are most with the highest price, yeah. And when we see the Volvo and Jaguar and others, we could scroll it down, yeah, and see that Chevrolet is with the smallest value. Again, let's explain this BMW and ask for highest value, and we see the engine size, so it's not telling so much to us, but we see these associations and can explain this in a very interactive way. Yeah. Okay.
We soon will move to questions, so that you know.
I think that's it. What I wanted to show, so we could ready for questions.
Okay, thank you very much. About the correlation and causation, I couldn't not remember all the examples that all the listeners also, you can try to Google hilarious examples that correlation doesn't mean causation. And did you know that the number of people who drowned by falling into a swimming pool correlate well with the number of films Nicolas Cage appeared in? So as you previously mentioned, that yes, if I eat more chocolate, does that increase my chance of getting a Nobel Prize? Probably not, so you have to be careful. First, we have for you a comment from Oleg, who says thank you for presentation. It is always useful before concluding on correlation to do some EDA analysis and visualize data and the data set. And in addition, correlation only causes on linear relationship between variables. If variables correlated non-linearly, then the correlation is not meaningful. More valuable to build regression and measure the p-value, AIC, BIC, etc. Much faster than building R. Can you comment that it is much faster than building in R?
This last one, could you repeat, please?
More valuable to build regression and measure the p-value and measure one p-value to AIC than BIC, etc. And the correlations plot is great, much faster to build in R.
Much faster to build in R. Yeah, sure. Yeah, because let's say R, and it depends. You could actually, if you talk about the environment where you do that, like it's R or it's some prepared visuals. Like in Power BI, you will have this R core plot that is already created visual that is embedded inside into Power BI. It's usually it's faster and easier to use a tool you are familiar with. So if it most important, I think, is to use right mathematical model behind the visual, because if you are building something yourself, it's in Excel, because you could calculate correlations manually in Excel using formulas. Um, I suggest to use some proven libraries, like Corplot is a large library, R library, and usually R libraries are created by scientists and statisticians. So it's a proven, so it's have had a right mathematics behind that. So that's most important.
Okay, thank you for the answer. The next question is interesting. Previously, we talked that I was taught Excel in secondary school, and in university, I was taught SPSS. And the user asks, do you think that Power BI can beat SPSS in data analytics?
I'm working time to time. I'm using SPSS also. I think that not really. So it's a different tool set, different tools really, because SPSS is designed especially for statistical analysis and more for statisticians when you need to get more details, because in SPSS mainly you will get as a result you will get much more details and figures, when in Power BI you getting more visuals. So you will get this visual result to have them. Let's say if we compare briefly SPSS and Power BI as it is now, like for today, we don't know what we will have in 5 years. That's all. But if we compare them today, so if you need to get more details, like when you do a correlation, you will get, or correlation, you will get one visual, like here we see that one visual, but in SPSS you will get more details. So, and if you are if you are data analyst, or you need to decide what to do, it's enough to have visual. But if you do some specific thing and you're doing research, for example, you need more details, and SPSS provide these more details. Of course, SPSS a little bit catching up on this analytical game, and they need to invest more in machine learning and capabilities and in visualization capabilities. But still, SPSS is very popular in Latvia. I could say that many organizations in Latvia, in banks, in state organizations, are using SPSS.
All right. Thank you for the answers. We have run out on time. Thank you.